Hello everyone, welcome to my class. In today's class, I will start chapter 8, further applications of integrations. So let me start the class right away. Let me give you the first overview. In chapter 6, we studied using definite integrals to compute the areas between curves, volumes of three-dimensional solid, work done by force, and average values of continuous functions. So now in this chapter, we explored some other geometric applications of integrations, such as arc length, area of surface of revolution, center of mass. So in today's class, I will cover arc length, section 8.1, which is the distance measured along a plane curve. The key idea is the distance formula. We want to determine the length L of the curve y equals to fx on AB. So the idea here is partition the interval AB into smaller subintervals with equal length delta x. Here is I label my subintervals by here is A, which is x0, then x1, then x2, dot 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 xi minus 1, xi, dot 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 xn. And if yi equals to f of xi, then point pi with coordinate xi comma yi lies on the curve. That means we have a point on the curve which is p0, p1, p2, dot 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 pi, dot 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 pn. Then we join those points, then we have a polygon here. Then the length of the curve is approximated by the length of the polygon. So to find the length of the polygon, first let's find the distance of any arbitrary piece here, pi minus 1 to pi. To find the distance, we use the distance formula, joining these 2 points. So the length between pi minus 1 and pi equals to, using distance formula, under the radical xi minus 1 outside is square plus yi minus 1 outside is square, which equals to delta x square plus delta yi square. And we know by mean value theorem on interval xi minus 1 comma xi, fxi minus fxi minus 1 equals to f prime xi star times xi minus 1. So here xi star is a point in the interval xi minus 1 comma xi. Then it gives me delta yi equals to f prime xi star times delta x. Then we put this value back here. Then this gives me radical 1 plus f prime xi star square times delta x. Then let's put this value back on here, and to get the exact length we have to take the limit as n goes to infinite. So then L equals to limit n goes to infinite, the summations I runs to 1 to n, the distance between pi minus 1 and pi. Great. Now with this idea we can define the arc length of the curve y equals to fx on AB by L equals to this limit, and the sum becomes the definite integrals from A to B. Under the radical, I copied from star equations, which is 1 plus f prime x square times dx. We can rewrite this formula as arc length L equals to the definite integrals from A to B. Under the radical, 1 plus f prime x is simply dy over dx, then outside is square times dx. With the same idea, if our curve is defined as x equals to function of y in the interval CD, then our arc length will be here. Definite integrals from C to D under the radical 1 plus dx over dy, outside is square times dy. Great. Now let's move on. Now we define the arc length functions, the distance along the curve measured from a fixed point to an arbitrary point by this arc length formula, we just replace the upper limit by x, and we already use x, then I use t here on this formula. So then Sx equals to the definite integrals from a to x under the radical 1 plus f prime t outside squared dt. Great. Then we use fundamental theorem of calculus. Then take the derivatives both side here. So the derivative s becomes ds over dx, and in the right side derivative and entire derivative cancel out. Just replace t by x. That becomes under the radical 1 plus f prime x outside square, which is same as under the radical 1 plus dy over dx square multiply by dx. This becomes ds equals to under the radical 1 plus dy over dx outside square times dx. Great. Let's move on. We can rewrite our arc length formula in one single formula by using arc length functions. So the arc length L equals to then definite integrals of ds from a to b, where ds equals to under the radical dx outside square plus dy outside square, which equals to, if you multiply and divide both sides by dx, this gives me this expressions, and if you divide and multiply by dy, then this gives me this expression. So keep in mind that the differential in the denominator of derivatives must match up with the differential in the integrals. Here is the dx, here is the dy, here is the dy. Great. Now let's move on. Now let's do some example. Find the arc length of given curve given by y equals to radical 1 minus x square from x equals to 0 to 1. So here this curve is, if you square both sides and simplify, this gives you x square plus y square equals to 1, which is simply the unit circle. And we are measuring the arc length from x equals 0 to 1, which turns out to be this, just a 1/4 of the unit circle. Great. So let's begin the solutions. First start taking derivative. So given function is y equals to radical 1 minus x square. This radical is same as the power 1/2, which I wrote here. Take the derivatives. Let's apply the chain rule. So the dy dx equals to, bring 1/2 as a coefficient. Then 1 minus x square power 1/2 minus 1 is minus 1/2. That means, which is here, I bring this power minus 1/2 in denominator and put the radical, and by chain rules take the derivative of inside function, which is simply negative 2x here, and simplify. This turns out to be negative x over radical 1 minus x square. Great. Then apply the formula. Then our arc length formula is L equals to definite integrals x equals to 0 to 1 under the radical 1 plus dy over dx square. So which turns out to be this one, 0 to 1 under the radical 1 plus x square over 1 minus x square, because this radical and the square cancel in my denominator. Let me scroll down and simplify. So multiply this 1 by 1 minus x square and add x square. That x square cancel out. Then we have definite integral 0 to 1 over radical 1 minus x square dx. Take the entire derivatives. So the entire derivatives of 1 over radical 1 minus x square is simply sine inverse x. And put the limit x equals 0 to 1. Sine inverse 1 becomes pi over 2, and the sine inverse 0 is 0. So the answer is pi half. Great. Let's move on. Example 2. Find the arc length of the curve given by y equals to x to the power 3/2 from x equals 0 to 4. The curve is a semi-cubical parabola, which is this curve, and we are only interested to find the length from x equals 0 to 4, so only this much. So begin the solution, start taking derivatives. Here f prime x turns out to be 3/2, x power 3/2 minus 1 is 1/2. and find the value of these expressions. 1 plus f prime x outside is square. This is the expression we use in integrand function under the radical. It turns out to be 1 plus 9/4, simply x. So by arc length formula, L equals to definite integrals from x equals 0 to 4 under the radical 1 plus f prime x square dx equals to definite integral 0 to 4. We computed already the under the radical terms here, so which is under the radical 1 plus 9/4 x dx. And it's a good candidate for u substitution. Let me scroll down. Put u equals to 1 plus 9/4 x. Take the derivatives. Du equals to derivative 1 is 0. So simply 9/4 dx. Then rewrite the integral in terms of u. Then your new integral becomes integrals. This is radical u. And dx becomes 4 over 9 du. Then integral of radical u is u to the power 3/2 over 3/2. You flip the 3/2. Then this becomes 2/3. And resubstitute the variables. So u power 3/2 becomes 1 plus 9/4 times x to the power 3/2. And this 4/9 is here as it is. And put limit x equals 0 to 4. I hope this computation makes sense to you all here. And the next, put x equals to 4, simplify, put x equals 0, simplify, subtract these two values. Then this gives you 8 over 27 times 10 to the power 3/2 minus 1. So that's our final answer. Using calculator, we will get approximately 9.07. Awesome. So let me take a moment to give you a quick side note here. Sometimes computing the arc length is messier because the integrand functions involves the radical. That's why our answer is also looks terrible here. If you don't have calculator, then this is our final answer. Awesome. Let's move on. So example 3. Find the exact length of the curve given by y equals to x to the power 4 over 4 plus 1 over 8x square on the intervals 1, 2. And begin the solution, just the routine computations. First start taking derivatives. Here's y prime turned out to be x cubed minus 1 over 4x cubed. Then find this value of these expressions, 1 plus dy over dx square. It turns out to be 1 plus this expression is square. Fold this expression. So in the next step, 1 plus as it is. So here, the first term square is x to the power 6 minus 2 times first terms times second terms turns out to be 1/2. X cube cancel. And plus the second term square becomes 1 over 16 x to the power 6. Now simplify this expression. This turns out to be x cubed plus 1 over 4x cubed outside is square. And that's good because our integrand function is under the radical. Now we got square. That means square and under the radical cancel out. Great. Hence, our arc length formula L equals to definite integrals x runs from 1 to 2 under the radical 1 plus dy over dx outside is square times dx. Next step, definite integral 1 to 2. We already computed this expression under the radical here. So then give the radical. So then square cancel. So we only have x cubed plus 1 over 4x cubed. We can take easily integrations. So take the integration next step and put the value x equals to 2 upper limit and minus x equals to 1 lower limit. Simplify. It turns out that the arc length of given curve between x equals to 1 and 2 is 123 over 32. Awesome. I hope this computation makes sense to you all. Now let's move on. Let's do example 4. Find the exact length of the curve given by x equals to 1/3 times radical y times y minus 3 on the intervals 1, 9. These are the y limits. Good. Let's begin the solutions. X equals to 1/3 times this radical y is y power 1/2 and FOIL inside, so radical y power 1/2 times y is y power 3/2 minus 3 times radical y, which is y power 1/2. Great. Then take the derivative. Here we are taking derivative with respect to y, so dx over dy equals to, its derivative turns out to be 1/2 times y power 1/2 minus y power minus 1/2. Compute these expressions, which is 1 plus dx over dy square turns out to be this exactly what we did in example 3. Simplify turns out to be radical y over 2 plus 1 over 2 times radical y, outside is square. Great. Then let's apply the formula. Then arc length formula, L equals to definite integrals. Now this integral is with respect to y, so y limit y equals to 1 to 9, which is given to us here. Then the formula is under the radical 1 plus dx over dy outside is square times dy. We already computed these integrand functions over here, so radical cancel this 2 and radical cancel, so we only have definite integrals from y equals to 1 to 9 of radical y over 2 plus 1 over 2 times radical y outside dy. Great, now we are integrating with respect to y. So here's 1/2 is outside, radical y means y power 1/2. So the integration of y power 1/2 becomes y power 1/2 plus 1, 3/2, and divide by 3/2 is same as multiplying by 2/3. So here that's 2 and that 2 cancel, so only 1/3 y power 3/2. Plus, similarly, the integration of 1 over 2 times radical y turns out to be y power 1/2. Same idea. So first bring radical y to the numerator, so this becomes y to the power negative 1/2. Then the integration of y power negative 1/2 becomes y power negative 1/2 plus 1, means plus half. Divide by 1/2 means multiply by 2. Then 2 and 2 cancel, so simply y power 1/2 left. I hope this makes sense to you all. Then put y equals to 9 minus y equals to 1 and simplify. It gives you the arc length is 32 over 3. Awesome. Now we finish the arc length in today's class. Thank you.